Alrighty. Number 11. SQ bisects angle RST. So RST is the large angle here. So if it bisects, that means that it cuts it in half or into two congruent pieces. So both of those smaller angles are going to have the same measure. The next part tells us that angle RSQ is 2x minus 4. Write an expression for angle RST, meaning the entire angle. Well, I know if this piece is 2x minus 4, so is this piece because they're congruent. So how could I represent the entire angle? By adding these two together. So 4x minus 8 would be an expression for angle RST. So that's it. Number 12. Zoom in a little bit. Find the midpoint of PQ. So first we need to make sure we understand the coordinates. So negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this is negative 4, positive 6. And this is 5, 6, 7, 8, negative 1, 2, 3, 4, 5, 6. So positive 8, negative 6. All right, our midpoint formula is adding our x values, cutting it in half, comma, add our y values, and also cut it in half. So our final answer is an actual coordinate point. Alrighty, so negative 4 plus 8 gives me 4. So 4 divided by 2. My y values, 6 minus 6 gives me 0 over 2. So 4 divided by 2 simplifies to 2. 0 divided by 2 is 0. So my final midpoint is 2, 0. Positive 2, 0. If you take a look, that means that this segment is the same length as that one. Number 13. Find the distance between points P and Q. Round to the nearest tenth. So distance formula, the square root of, I'll write this up here, distance equals x2 minus x1, the difference in x's, and the difference in y's. Okay, so I like to highlight my x values and then also highlight the y values. Just kind of keeps it in order if you can. Alrighty, so 8 minus 3 squared. Now y minus y. So 2 minus 8 squared. Alrighty, 8 minus 3 is 5. 2 minus 8 gives me a negative 6. Again, be careful when we are using a calculator to enter negative 6 squared because we need the parentheses, or just remember that anything squared is going to be positive. So 5 squared is 25, and 6 squared or negative 6 squared is 36. 25 plus 36 is 61. So square root of 61 would be our exact answer. But if I want to type this in on a calculator, square root of 61 to the nearest tenth, we look one beyond it, 7.8. So approximately 7.8. Add that to our answer. Alrighty. Use the diagram below for number 14. Identify a pair of alternate exterior angles. So let's first remind ourselves that we need a transversal cutting at least two other lines. So H is my transversal, and I'm going to look for the relationship with A and B. So exterior angles are anything on the outside of lines A and B. So angle 1 is on the exterior, and its alternate or opposite is 5. And my other set of alternate exterior angles are 2 and 6. So either of those pairs would work. Angle 1 and 5, or angle 2 and 6. Alrighty. Number 15. What is the relationship between angles 4 and 5? Just like the last example, we're looking for our transversal, a line that cuts two others. So we should notice that angles 4 and 5 are between M and N, so that means they're part of the interior. Are they consecutive on the same side of the transversal or on alternates or opposite sides? These are alternate interior angles. Alrighty. Number 16. Which statement is true? Angle FEG, so we're talking about this angle, and CBE, this one, are alternate angles. One is on the interior, one is on the exterior, so that is not true. Angle CBE, so this same angle, and DEB, this angle, are alternate angles. They are definitely not. They are consecutive interiors. Angle CBE, so again this angle, and DEB, right here, are same side or consecutive interior. That is definitely true. Because I'm a good test taker, I'm still going to read letter D just to make sure. FEG, so this angle here, and DEB, this angle here, are same side interior. Those are verticals. So we're good. C is correct. All right, we have another diagram. This diagram of airport runway intersection shows two parallel runways and a taxiway crosses both. How are angles 8 and 4 related? Well, I have 1 on the interior. Angle 4 is on the interior because it's between our two parallels. And 8 is on the exterior. So we remember that there is only one relationship where 1 is on the interior and 1 is on the exterior. And that's called corresponding as long as they're in the same position as each other. So angle 8 and angle 4 are in the same position. Just like angle 6 would be in the same position as 2. That angle 7 is in the same position as 3. And angle 5 is in the same position as angle 1. So those are all examples of corresponding angles. All right. Number 18. Find the value of x if L is parallel to M. So I know that these lines are parallel. So all of my angle relationships have some value. The diagram is not to scale. So what do I know about 2x and 64? These, just like the last example, are in the same position. So these are corresponding angles, and corresponding angles are the same measure, or congruent. So 2x is equal to 64. Divide by 2, x is equal to 32. And this just says find the value of x, so I am done. Number 19. Find the value of x for which P is parallel to Q. If the measure of angle 1 is 9x and the measure of angle 3 is 117. Again, I should recognize that these are corresponding angles, and corresponding angles are congruent. So 9x is equal to 117. So I'll divide both sides by 9, and I get 13. And that is it. Number 20. Is the line through points P and Q perpendicular to the lines through point RS? Explain. So we need to calculate their slopes. So let's find the slope of PQ. So slope is y2 minus y1, the change in y over the change in x. So P and Q, so I'm going to say that negative 13 minus a negative 10 divided by negative 4 minus 2. Slide off the page there. Okay, negative 13 plus 10 gives me negative 3. Negative 4 minus 2 is negative 6. If I simplify this, I get a positive 1/2. Now I'm going to do the same thing, but for RS. What do I expect to happen for perpendicular slopes? I would expect that my fraction is the opposite reciprocal. So I flip the fraction, so 1/2 turns into 2/1. And if I want it opposite, I want the opposite sign. So this positive slope would be negative. So that's what I'm looking for if it's perpendicular. So I have 4 minus a negative 2 is really 4 plus 2. 1 minus 4. So I have 6 over negative 3, which reduces to negative 2, or negative 2/1. So are these perpendicular? Yes, they are perpendicular. The upside down T means perpendicular. So if we look at our options, D is correct.